30, 40, or for 39 or 38. Please ask them to join this class. Okay. Okay, guys. So good morning. In the last class, we discussed law of gearing. Okay. Now today we continue the same topic today, the gear topic. Now, so this is, this is already we discussed. But just to recap, the same portion we discussed in the last class. So some of the information we didn't discuss. We discuss from this, then we go for the next today discussion. Okay. See here, this is gear, this is pinion. So before joining the other students, just we couple of minutes we discuss, then we move to next content today. Okay. Now see here, here we are looking only the two. We are looking only the matting teeth from the gear and the pinion, because for our understanding, this is the teeth we consider from this whole gear here. Gear, we considered one teeth. Which teeth is engaged with the pinion gear? Here also the right hand side we consider the toe. The whole pinion we consider only one teeth. Okay. Now, we know already where this pinion and gears are missing. Pinion gear teeth are missing. The pinion teeth, sorry, the gear teeth and pinion teeth are missing. That is the pitch point. Now, corresponding that point, we are draw a line. That is the, common normal. Common normal, that is called, we already discussed, the point is N. The line is N. Now, the same line we can draw such a way that is, now see here, this is the circle called base circle of the gear. This is a circle called the base circle of the pinion. These are the identification we should know while designing the gears. Now, okay. Now, what is the pitch circle? Which common point is passing through the circles of gear? Passing through the circle. So the gear and pinion passing through which common point? Corresponding circle is called the pitch circles. With respect to this common point, sketch line, showing that our pitch circle of the gear pinion. This is the along which line is passing through this point, common point, the gear point, gear's radius. Okay, that is pitch circle of the gear, or pitch circle radius of the gear also we can say that. Okay. Now, what is the pressure angle? In the last class also, I think we didn't discuss about that. Now, this is the line. This is the, we discussed already. This is the line. What is the line? Dimensions OG. Sorry, O to P. For gear side, for pinion side, O1P, right? O2P and O1P, where they're intersecting that point. In that point, I would like to draw a perpendicular line. Okay. Now, the angle between our common normal to this line, that is nothing but velocity at the pitch point. Now, that also we discussed. This velocity at the pitch point, we discussed this is the two common vectors, velocity of this gear and velocity of the gear and velocity of the pinion. From that, we able to draw that point. Okay, we discussed in the last class. Now, I am taking this perpendicular line from this pitch point. That perpendicular line is this line. Now, we have drawn the common normal. Now, what is the angle between this common normal to this perpendicular line? That perpendicular line is nothing but velocity of the pitch point. Velocity at the pitch point. Okay. This angle is representing the pressure angle rotated in the direction of driven gear. Now, so this is up to this. This is the pressure angle we didn't discuss last class. So that's what I would like to convey here. Now, this is pressure angle. Now, other remaining things are we discussed already. Angular velocity of the gear and angular velocity of the pinion. And these are the things we discussed while discussing. I mean, while when the power is transmitting with the help of this gear mechanism, the gear is rotating. For example, gear is rotating anti-clockwise direction, but the pinion going to rotate in clockwise direction. Now we come to this invalid. Now very important terminology. So in the earlier section, we discussed gear. I mean, law of gearing. The law of gearing. I mean, when the engagement and the disengagement, sorry, engagement and the disengagement of each teeth should follow the same point of contact. Same point of contact. That's what I told you that. For example, now this is the teeth one from the pinion. This is the teeth one from the gear. The next teeth, I mean, once the teeth engagement and disengagement, the other teeth will be coming. The teeth two from the gear, teeth two from the pinion should be contact with the same point. Then only we able to get the constant velocity ratio. That is the law of gearing. Now, similarly, that invalid also very important terminology we have to understand here. See here, there is infinite. Now, before now, I tell you clearly. Don't worry. Now, just see this statement. There is the infinite number of possible conjugate pairs could be used, but only few curves have been the practical application of the gear teeth. Now, what I'm telling here now, I mean, we already discussed the base circle, right? This is the base circle of the gear. This is the base circle of the pinion. From this, I'm taking base circle of the gear. Now, see, this is my base circle of the gear. Now, from this base circle of the gear, now I am taking this is a center point. Now I am considering some points from this point to this point. I'm taking. You may ask, sir, why can't take here? You can take. You can take from here also. You can take from here also. When you are taking more wider range, then your tooth profile going to be a more width. Okay. When you are taking small, your tooth profile going to be a smaller width. The teeth width of the teeth going to be small. Okay. Anyway, so based on that, now I am taking. Here now I am taking this point. Now first point I am considering from here. The another point is considering from here. This region only I am going to concentrate for defining my teeth profile. Now, how can I define here? Now, as I told you that infinite number of possible conjugate pairs that could be used here, but only few curves going to be a practical application for the gear teeth. What is the few curves? Now, for example, now maybe I'm considering this is the one curve, this is another curve, this is another curve. For our understanding purpose, I have drawn this like this curve. Now, in this, I take this another curve. Now, this is curve 1, 2, 3, 4. Okay, 3, 4. Now, I can take another, not only curve, I can take another straight line also. For our understanding, I can take another straight line also. Right? Now, see, the procedure we should follow. Now, I already told you that we have considered this point. This is the points we are going to consider for design of our gear now. Okay. Now, see, 1 minute, I take. Yeah. Now, see here. Now, this I am starting point here. I take from this starting point, I draw a tangential line. This is a line, tangential line from the base circle. Now, tangential line 1 base from the base circle. Now, I am taking another point from here, tangential line 2, tangential line 3, tangential line 3, tangential line 4, tangential line 5, tangential line 6, up to n number of points I can draw from this region. From this region, I can draw n number of tangential lines. From this point to this point, I can draw n number of tangential lines. Now, in these tangential lines, which lines are perpendicular, normal to the curve. For example, This whatever we have drawn the tangential line, those lines only, those lines are perpendicular to this profile. Now, when it will be perpendicular, then only we able to get this kind of invalid curve. For example, I told you I have drawn. Now, third curve is perpendicular to each line. Which line we have drawn tangential to the base circle of the gear. Now, I extend this now. Now I extend each line. Now I extend other line. Each line I extend to this straight line. Is it perpendicular? No. now, now I remove that. Anyway, you might have been understood that. Now I remove that one. Okay. Now the same line I would like to extend to this curve now. Same line I would like to extend to this curve. Now, when I am extending this curve, when I am extending this line, tangential line to this curve, right? Will it normal to this curve now? Is it normal? No. This is not normal. Now, this curve also not valid. This curve also not valid for our tooth, for design our tooth profile. Okay. Now extend, this is a curve 2. This is curve 1. Extend this line. Will it be normal to this curve? No. Hence, this profile also not valid for our design. Now I take a curve 4. This line, is it normal? Is it normal? It's not a normal. Then this curve also not valid for our design. Hence, whenever we are taking the range of these points, and each point we are draw a tangential line from the base circle, that tangential line at corresponding to which curve to normal. At each tangential line, when it will be normal to corresponding one curve, that is going to be considered for our tooth profile, tooth design profile. Similarly, you may draw this line from this point to this point, then you are going to get another such a like kind of tooth profile. Now this is one teeth. Now this is the teeth design. Okay. Now such a way that we are defining our tooth profile. So now this is very important terminology, invalid. The invalid, I mean, invalid curve is mostly in spur gear and helical gear. This kind of tooth profile we are following. Okay. Now, right? That's what. See the invalid tooth form. I mean the invalid of the circle is a curve that can be generated by unwarping taut of string from the cylinder. From the cylinder means nothing but base circle. That the taut string I'm considering multiple lines, which lines are tangential to the base circle of the gear. I mean, which tangential lines are drawn from the base circle, the tangential lines must be normal to the particular curve that is called invalid, that will be considered for our, I mean that particular design will be considered for our tooth profile, sorry, teeth profile. Okay, so this is called invalid. Now come to this, the string always a tangent to the base circle, whatever we consider the strings, 1, 2, 3, 4, 5, 6, 7 up to n, the strings are considered as a tangent to the base circle. Now the tangent invalid is always normal to the invalid. The strings are normal to the invalid. That's what this point representing. So this is the teeth profile. I mean, this way only we are doing the teeth profile design. Okay. Now this is very important concept. Now, I mean, whatever we discussed the earlier figures, the two invalids or separate cylinders are meshed to each other. Two invalids. This is one invalid. This is another invalid. This is one invalid. This another invalid to mesh to each other. I mean, this invalid designed with respect to the base circle of the gear. This invalid designed with respect to the base circle of the pinion. Okay. Okay, so now this, see here, this is another example diagram from this. Now I am considering the point from here. The each line must be normal to this curve, that will be acting as a our teeth profile for teeth design. Now, see, see here one more thing. Now, the teeth profile. Now we consider the invalid curve. Not only invalid curve, based on our application, the teeth profile may be cycloid. That's what the cycloid is still used for the tooth design or tooth form in some watches and clocks, but most of the gears we are using invalid of profile, or invalid shape for our application. Now I come to this. Some more points we discuss about the cycloid curve. Okay, the cycloid curve is traced by the point on the circumference of the generating the circle. Now, I take, okay, the cycloid curve. Cycloid is a curve traced by a point on the circumference of the generating the circles as it rolls without slipping along the inside and outside of the circle. I tell you what is inside and outside of the circle. Now, see here. Now, this is the base circle. This is our base circle. Okay, this is our base circle. Now, the cycloid is a curve. This kind of profile is followed the ellipsoid and hypoellipsoid. That's what the cycloid profile is followed by the two curves. One is the epicycloid, epicycloid. Another one is hypocycloid. Sorry, epicycloid and hypocycloid. When we are going for our tooth profile by using cycloid curve, then we have to follow epicycloid and hypocycloid curves. What is epicycloid curves? Now, epicycloid curves, epicycloid is a curve traced by the point on the circumference of a generating circle as it rolls when the matting here is rolls on this base circle without slipping, but outside the base circle. This is epicycloid. Okay. Now, a hypercycloid curve traced by a point on the circumference of the generating circle rolls without slipping at the inside the base circle or pitch circle. Inside of the pitch circle. Inside of the pitch circle or base circle. Okay. Now, see here, the gear tooth profile is based on the epicycloid and epicycloid and hypocycloid curves, which are curves generated by circle rolling around the outside of the circle, around the outside here. This is around the outside. Okay. And the inside another circle, that is hypocycloid, the gear design. Hypocycloid, respectively. This ensure the motion one gear is transferred to the another at locally constant at angular velocity without a slipping effect, while two gear teeth are matching and transmitting both during that time at the inside profile of the gear and outside of the gear. It should not be slipping. Okay, slipping. So this is the cycloid curve, but mostly we are using invalid. Most of the mechanical application we are using invalid profile. Okay, now terminology, just we go through the terminology because I thought to discuss in the last class, but I missed out. Now we discuss the terminology. Okay, now this is the terminology one by one we discuss. These are very important. As a mechanical engineer, we should know what are the terminology we are using here. Now, pinion we know very well is a smaller gear and it's a smaller smaller, I mean, pin is the smaller of the two matting gears, right? Gear is larger of the two matting gears. Now, one by one we will see here. Now pitch circle. Okay, I remove this. Pitch circle. Pitch circle is a theoretical circle upon which all computations of the gears are based. Okay, pitch circle I already told you, based on the common point of contact. Okay, two matting gears. The pitch circles of a pair of matting gears, the tangents to each other. The diameter of the pitch circle also called pitch diameter. We already discussed the pitch point. Okay. Now I come to this next one, addendum circle. What is the addendum circle? I mean, it is the circle passing through outer ends of the teeth of the gear. The diameter, it is the diameter, largest diameter. What is addendum circle here? I mean, see here, addendum circle. Addendum circle, I mean, the circle passing through the outer ends of the teeth. This is the outer end of the teeth. This is addendum circle. Okay. Now come to the next one. Now dedendum circle or the root circle. Dedendum circle or root circle. Dedendum circle or root circle. It is a circle passing through the bottom of the space. Where is the? I mean this one. Dedendum circle. Okay, dedendum circle. That is the passing through the bottom of the space. See, bottom of the space. Okay, dedendum circle. Next one. I mean, addendum. What is addendum? It's a part of the tooth above the pitch circle. I mean, from the pitch circle, what is the distance? From the addendum circle to pitch circle, the distance is addendum. Now, dedendum. I mean, this is the pitch circle to dedendum circle. What is the distance? Below the pitch circle. Distance. The distance from the pitch circle to below pitch circle to dedendum circle. That is dedendum, the distance. The pitch circle, the distance from the pitch circle to above addendum circle, that is, I mean, addendum circle is called addendum, the distance. Okay. Now, next one is dedendum. I told you that. I mean, the part of the tooth below the pitch circle, this portion, dedendum. These are the things necessary when we are going for designing the gear. Face, it is the bearing surface of the addendum. This, I mean, when the two gears are meshing, this surface. Okay, now it is the bearing surface of the addendum. This is the face. Now, flank. It is surface of the dedendum, where this is the below the pitch circle. Below the pitch circle, the area which area going to be contact with the matting gear, that is the also called the flank surface. That is also called flank surface, also surface of the dedendum. Okay. Now I come to the next terminology, profile. It is the curve. I mean, whatever we just now we discussed, the curve forming the face and flank. I mean, this curve forming the face and flank. What is this curve? Just now we discussed. No, what is this curve?
Invalid.
Yeah, invalid. Thank you. Now, next root clearance. Now, see here, root clearance. It is the difference between the addendum and the dedendum of the matting gear. I mean, addendum. This is the difference between the dedendum and addendum. What is the difference between the addendum and the dedendum? Dedendum minus addendum difference is giving as the root clearance. This root clearance, I mean, based on our fillet radius. Why do we need fillet radius? As we studied in the last subject, I mean, the corner surface always more stress concentration. We would like to avoid the more stress concentration effect. Hence, based on the gear design, based on the size of the gear, now they are using the fillet radius to avoid the corner surface. Now, I mean, our detentum is passing through the this line. Detentum passing through the detentum circle, but this line is passing through this almost in the fillet radius, above the fillet radius. This is the clearance. Sometimes you may consider the fillet radius also. Okay, this is root clearance. Now, next one is depth of the gear. What is the depth of the gear? The sum of the addendum and the detentum. That is depth of the gear. Okay. The working depth of the gear is the depth of the engagement of the pair of gears. That is the sum of their addendums. I mean, see here, whole depth means, I mean, including detentum circle plus, addendum plus detentum. But working depth means even working depth. I mean, when the other gears, other teeth is going to be engaged here, other teeth is going to be engaged here, right? Now, other teeth engaged here. Now, during that time, should not touch here, should not touch on this surface. Then wear and tear will be more. Only up to this. Okay, that is what we are considering the working depth. It causes the more wear and tear, damaging the bottom land or bottom surface. Hence, this up to this depth only we are allowing. That is working depth of the gear. Now, next one is width of the tooth. Width of the tooth. Sorry. Width of the tooth, the width of the space between the measured along the pitch circle. Now, this is the width of the space in between two gear. Width of the space. Here also called this is the width of the space between the teeth measured along the pitch circle. We have to measure the width of the tooth along this pitch circle from from this point to this point, width of this space. Now, tooth thickness. Tooth thickness we are measuring from the width, each tooth thickness we are measuring corresponding to the pitch circle of each teeth. Each teeth going to be same width only. We are measuring at corresponding the pitch circle of the teeth. Now, what is the circular pitch? Circular pitch. Okay, anyway. Circular pitch. Okay, one by one. Thickness of the teeth, I have told you that. The thickness of the teeth measured along the pitch circle. What is the circular pitch? Okay, top land. Okay, top land. This is a top land. This is a bottom land. Okay. Now, bottom land we discussed. Okay. Anyway, circular pitch. Some of the missing things we discuss later. Circular pitch is nothing but tooth thickness plus width of the space. We can say like that. Or from here to here. We have the formula. We will discuss later. Now, one by one. What are the missing things? Some of the terminology I missed out. Those things I have taken from your book, Bandari book. Just I tell you that velocity ratio. Once complete that, then we go for this one. What is the velocity ratio? Velocity ratio is the ratio of the angular velocity of the driving gear to the angular velocity of the driven gear. Or you may say that speed ratio. Right? Now, transmission ratio. Second terminology. Other terminology. We already discussed many terminology. Now, velocity ratio, I told you that. Now, I'd like to tell you that transmission ratio. The transmission ratio is the ratio of the speed of the first driving gear to the ratio of the speed of the first driving gear to the angular speed of the first driving gear. We already discussed during gear train. Different gear trains we discussed. In that, what finally we came to know that the ratio of the angular speed of the first driving gear to the angular speed of the last driven gear. That is the transmission ratio. Especially the transmission ratio we are using in the gear train when we are accessing more than two gears with appropriate orientation. I mean, appropriate orientation means it may be connected, the gears, more than two gears may be connected in single shaft, or intermediate shafts connected more than two gears, and end shafts are connected single gear. Based on that, we discussed in the last class. So, gear transmission ratio, mostly we are using the terminology in the gear train. Sorry. Now, pitch circle we discussed. Now pitch circle, pitch circle diameter. Now see here, pitch circle diameter. Pitch circle diameter is the pitch circle diameter is the pitch circle diameter is the diameter of the pitch circle. The size of the gears usually specified with based on the pitch circle diameter. Now pitch circle diameter we are putting the notation d dash. We are putting the notation d dash. Now this is the pitch circle diameter, what we discussed earlier. This is the pitch circle diameter. Okay, D dash. Now, we already discussed top land, bottom land, invalid, base circle, we discussed addendum circle, dedendum circle, we discussed. Now, clearance also discussed. Face of tooth, we discussed, and the flank tooth also we discussed. Now, face width. Now, face width also, face width. Where is the face width? This is the face width. We already discussed the face width. And now circular tooth thickness, that I'll also discuss already. Now working depth, hole depth, center distance. Okay, center distance is the distance between the centers of pitch circle of matting gears. Okay, that is center distance. Now pressure angle we already discussed. Okay, now arc of contact we didn't discuss. The line of action is the common tangent. Sorry, arc of contact is the arc of contact. Sorry, arc of contact is the arc of the pitch circle through which a tooth moves beginning and end of the contact. I tell you here without seeing this. Okay, 1 minute. I want to show you this diagram. Then only you can easily understand arc of contact. See here, the arc of contact is the arc of the pitch circle through which the tooth moves from beginning. See here, here this is our pitch circle in between, right? Through which the tooth. That's what the arc of contact is, the arc of the pitch circle through which a tooth moves. The tooth moves beginning of contact and end of leaving. That is arc of contact. Right? When, see, for example, this gear I am taking before contacting, that is the beginning of contact, and after leaving from the contact, now here engaged, here left, here engaged, here left, the teeth is engaged here. While through the pitch circle means each gear, each teeth now following same point of contact. That's what we discussed in the law of gearing. Hence, that's what I am saying here. Arc of contact is nothing but mean that the pitch circle, the arc of contact, the arc of pitch circle through which teeth moves from the beginning before touching this common point with the gear teeth. Okay, beginning to the end of the contact, beginning at the end of the contact, how much distance covered, that is arc of contact. Now this arc of contact, I can say that summation of arc of approach, arc of recess. What is arc of approach here? Arc of approach is nothing but arc of approach is the arc of the pitch circle through which tooth moves beginning of the contact. Now see here, the teeth is coming here, coming here. Beginning of the contact, how much distance moved along the pit circle? That is arc of approach before contacting this. For example, now I am taking a pinion gear. Sorry, now I am taking pinion teeth. Pinion teeth before touching or before matting with the gear teeth, how much distance it traveled in the pit circle? That is arc of approach. Once beginning touching the matting teeth, once engagement happened and at the common point of contact, then how much distance traveled up to ends? That is arc of recess. Now, arc of contact equal to arc of recess plus arc of approach. That's all. Are you clear? Any doubt? Guys?
No, sir.
Okay. Okay, thank you. Now, I mean, these are the important terminology. Now, contact ratio. The number of pairs of teeth are simultaneously engaged is called contact ratio. Okay. As the two gears rotate and smooth and continuous transfer the, okay, again I come to the same diagram, same movie, I mean same video, you can easily understand. I mean, there are two, I mean, the number of pairs of teeth that are simultaneously engaged is called gear ratio, contact ratio. Okay. As the two gears rotate, I mean, either gear or pinion. You may consider two gears or pinion or gear rotates. As the two gears rotates, smooth and continuous transfer the power from one pair of meshing teeth. Here, one pair of meshing teeth continuously. With this one pair of meshing teeth. Okay. Following one pair of meshing teeth to following the pair is achieved when the contact of the pair continuous until following the next pair as established the contact. This is contact ratio. Anyway, this is, go through your book, you can get it more clarity. This is one of the terminology. If you are not getting, I tell you. Okay. Now I come to this. I mean, now this is the circle. Now I come to the circular pitch. Circular pitch is now, I mean, we already discussed circular pitch. From here to this is a circular pitch. What is a circular pitch? In general way, what is the number of teeth? If you know the number of teeth, we are able to easily find out circular pitch, because the circular pitch which it depends on the number of teeth, right? Suppose more number of teeth are designed in the circumference of the cylindrical wheel, that is called the gear, right? More number of teeth, then less circular pitch. Hence, our circular pitch based on our number of teeth. Then we know the circumference. This d dash is nothing but our diameter, pitch circle diameter into pi d. Pi d is our circumferential dimension, right? Divided by z, number of teeth. It will give us the pitch of the circular pitch dimension, p, small p. Now diametral pitch. The diametral pitch P is the ratio of the number of the teeth to the pitch circle diameter. I mean, this is nothing but the ratio of the number of teeth to the pitch circle diameter. It will give the pitch of this diametral pitch. Is that by d dash? Now multiply P, small p and capital P, which will give you the pi. This is very important terminology. These are the terminology we are going to use in our design calculation. Keep in mind. Okay. Now I come to this module. Module is nothing but, these are the standard terminology we are using for the design analysis. The module is nothing but 1 by capital P, 1 by diametral pitch, also called d dash by z. D dash by z. This is module is equal to 1 by pitch. That is, model is inverse of diametral pitch is called model, because the model we are going to define I mean, sorry, our addendum and dedendum of the gear we are going to define in terms of module later. Okay, now this is module. Now, what is the center distance between the two gears? I mean, two gears we are defining in terms of number of teeth. We are going to define in terms of number of teeth. I mean, even some of the information we already discussed. Now, see here. Now, this another matting gear this side, another matting gear or pinion this side. Okay, sorry. Okay, now what is the center distance? Now this distance we are finding, this is a gear 1 or pinion, this is a gear, okay, 2 or both are gear. Okay, now what is the center distance? Center distance is 1 by 2 pitch circle diameter of the pinion, pitch circle diameter of the gear divided by 2. Now m is at p. This is from the model. The model. Now from this model we know this. Now d dash. D dash is nothing but pitch circle diameter. Commonly we consider pitch. Pinion means p. The gear means it will be a super subscript g. Now m into z. M into small m. M into z p. Okay, pinion. Now now instead of p dp and dg, I'm putting this. Finally, this is our center distance between the pinion and gear, or two gears. Center distance, number of teeth on pinion, number of teeth on gears. Now, right, I mean speed ratio we already discussed. Now, okay, now I come to this. Now the number of gears, number of methods or manufactured gears, they includes the casting, blanking and machining. I mean, casting process also we can do, direct casting process we can do, manufacturing of gears. But I mean, we need, even though we need a finishing process. Okay, however, the power transmitting gears are made with the help of this milling process, rock generation process, hobbing process. These are the method we are using for, I mean, preparing the power transmitting gears. Now I come to the standard system of gear tooth. Now, I mean this. Now, before entering into this, I would like to tell you some more information here. Now, I mean the standard method, standard system we are going to follow in the invalid profile of the gear teeth. I mean, some of the reasons I would like to tell you here. The first reason, the invalid profile satisfies the fundamental of gearing. Obviously, right? Invalid profile always satisfy with the fundamental of gearing. Okay, the invalid gears given module and pressure angle are completely interchangeable with respect to each gear, each teeth. Sorry, with respect to each teeth. The invalid of gears given module and pressure angle can be machined from one single tool, because the invalid profile for each teeth, while you are manufacturing, during that time we have to use a single tool to design, to machining them, then only we able to manage the accuracy of each teeth, then able to follow the, then it will be easily satisfied with the our law of gearing. Okay, now these are the things we should follow. And there are three standard systems of safe of gear teeth. One is, I mean, 14.5-degree full depth invalid system. Okay, and 20-degree full depth invalid system, and now 20-degree subtooth invalid system. These are the three standard system. All most of the industry we are following the standard system while preparing the gear. Now see here. Now what is this? This is the dedendum. The dedendum is defined in terms of module. What is a module? Module is nothing but 1 by, what is a module? I mean 1 by diametral pitch. 1 by diametral pitch here. I mean 1 by diametral pitch. Diametral pitch is nothing but z by d dash. Number of teeth divided by pitch circle diameter. Now this is, I mean This is, I mean, for example, 14.5 full depth invalid system. Here, this is a model one time. This is addendum design. Addendum diamonds should follow one, I mean, model. Okay, but the addendum should be 1.157. See here, this is the angle. This angle is 14.5 degree. This is called a full depth invalid system. Okay, full depth invalid system. Now, full depth 20-degree full depth invalid system. This is a 20-degree full depth invalid system. This 20-degree full depth invalid system. See here, the dedendum dimension is 1.25 times of model. Now, subtooth invalid system. Here, dedendum size is one model, but addendum size is 0.8 times of model. 0.8 times of model. Now, I mean, this is for, I mean, this is the original view of 14.5-degree full depth teeth, single teeth. This is a 20-degree full depth of teeth. This is a 20-degree subtooth invalid system teeth design like this. Okay. Now, when the system, now this is a model. One, when the model is small, the number of teeth will be more. You come to the relation here. Now, model is small. Model is small. The number of teeth will be more. See here. I mean, model is small. Number of teeth will be more. The result will come here. Just now. I mean, Z is equal to D dash by M. When M is decreased, number of teeth will be going to be more. Number of teeth will be more. N is equal to 2. M is equal to 2. M is equal to 3. M is equal to 4. M is equal to 5. When the module is more, the number of teeth will be less. The teeth size also going to be bigger. Bigger. Okay. This is the now, I mean, when the increasing the pressure angle improves the tooth strength. When we are increasing the pressure angle, increasing the tooth strength, but it shows the, I mean, duration of contact, decreasing the duration of the contact, decreasing the duration of the contact, while increasing the pressure angle. But when decreasing the pressure angle requires more number of teeth. When decreasing the pressure angle requires more number of teeth, during that time the model is less. When increasing the pressure angle improves the strength of the improve the strength, and but the duration contact duration between the matting gears going to be less. During that time we should follow the max, the module will be high. That's what I would like to tell you here. When decreasing the pressure angle requires more number of teeth, more number of teeth, I mean more number of teeth on the pinion, and it can be used to avoid undercutting. What is the undercutting? We will discuss later. It can be avoid the undercutting. So, I mean, mostly 20-degree pressure angle. 20-degree pressure angle is a good compromise for most of the power transmission design or power transmission gear design. Power transmission gear design. Okay. Now, and also, I mean, 20-degree pressure angle is it is reduce the undercutting. I tell you under what is undercutting later. Okay. Reduce the undercutting, reduce the interference. I tell you the interference undercutting separately later. Okay, undercutting and interference. When we are following, I mean 20-degree pressure angle as compared to 14-degree 0.5 pressure angle. 20-degree pressure angle, it will be reduce the undercutting, also reduce the interference, okay, due to increase the pressure angle. And also, I mean, the greater length of the contact when we are going for 20-degree full depth, greater length of the contact also more. Now I come to this another further this crowning. What is a crowning? These are the important terminology we didn't discuss earlier. I mean, crowning, strengthening of the gear, Strengthening of the gear is called crowning. I mean, the crowning is nothing but, I mean, the strengthening of the gear is it's strengthening of the gear teeth, strengthening of the gear each teeth or tooth. Okay, that is called crowning. Now, I mean, during the operations, there is an uneven distribution of the pressure. Okay, yeah, here I have given clearly. I mean, strengthening of the gear is strengthening of the gear tooth is called crowning. Okay, I mean, during this operation the distribution of pressure along the face with going to be high. Okay, I mean, that's what during the crowning operation there is an uneven distribution of pressure going to be face of the gear tooth, gear each teeth. Okay, now what are the, I mean gear tooth face with, I mean, due to what is the reason? What are the reason for uneven distribution of pressure on the face of the tooth? I mean, there are three more reasons. One is inaccuracy of tooth profile. Inaccuracy of tooth profile going to be a uneven distribution of pressure. Okay, and errors in assembly of matting teeth. I mean, errors in assembly of two two gears, that also causes the uneven distribution of pressure. So another effect, another reason uneven distribution of pressure along the face with, another reason is effect of elastic deflection of the shaft. Here, effect of the elastic deflection of the shaft due to the gear tooth force and bearing reactions. So, I mean, that's what we already discussed: shaft dimension, shaft design, and bearing reactions. I mean, that's what how much bearing, the bearing design and the shaft dimensions also we already I mean, especially we already discussed shaft design based on the gear power transmission capacity in the problem. We already discussed when we considered the tangential load, radial load acting on the gear. Based on that, how much dimensions of the shaft we already discussed. Hence, this is also another reason. I mean, due to uneven distribution of the pressure along the face width, the another reason effect of elastic deflection of the shaft due to the gear tooth force, and bearing reactions. Anyway, bearing we not have discussed, but gear based on the gear design, based on the load, how much load, tangential load, radial load, and I mean resultant load were acting in the gears. Based on that, we discussed the shaft dimension. Shaft dimension. So this is another reason for uneven distribution. So we should take care of it while designing the shaft. Okay. Now I come to this standard invalid. I mean, the table only we have given you this terminology 14.5 degree full depth system. During that time you have to consider the alpha pressure angle, alpha 14.5 model, addendum is single one model, and dedendum is 1.157. The clearance we already discussed 0.157 times of model. The working depth will be 2 times of model. The whole depth is 2.157 of model. Now tooth thickness is going to be 1.57 times of model. If we consider only this statement, we have to follow this for our design of the gear. 20-degree full depth in depth system. During that time, we have to follow this terminology, empirical relation. I mean, this is obtained from the design data. Sorry, this is obtained from the design data. We should follow this term. I mean, values in our gear design. Also, I told you that 20-degree full depth system is better for, I mean, better means we can avoid undercutting, we can avoid the interference. We can reduce the interference, we can avoid the undercutting, those things we will see the later. Undercutting, what is the interference, those things. Our gear trains we discussed. Now just I recap one within 2 minutes. I mean each shaft carries only one gear. That is simple gear train. Now, I mean this is the compound gear train. Each shaft except first and last, this first shaft, input shaft, driver shaft, and driven shaft carrying one gear or one pinion, but intermediate shaft going to be connected with more than two gear, at least two gear or two gears or combination of gear and pinion. Now this is the reverted gear train. First and last gears on the same shaft, but each shaft going to have more than one gears. Okay. Now this is epicyclic gear train. One gear is fixed, and meshing gear is has motion composed of the two parts. This one. This is a fixed gear. This it's like a sun gear. You might have been studied in your KOM subject. Sun gear. This is the planet gear. This is rotate with respect to one axis as well as rotate with respect to the sun gear axis. With respect to sun gear axis along the circumference of the sun gear axis. Okay, this is self rotation as well as rotate along with the sun gear axis. But I mean, so planet gear is at the same axis only. With planet gear rotation with respect to fixed gear. I mean, this is a fixed gear, sun gear. Only the planet gear rotates their own, and with rotate with respect to sun gear axis. Okay, now come to this. Now this is the back loss. Back loss. I mean, width of the tooth space exceeds the thickness of the engaging. The tooth measures along the pitch circle. I will give you clear explanations about the backlogs later. Okay. Now just see here this gap. Now this gap rises the backlogs. Just keep in mind. Now I will give you some more explanation. Now this is should not happen. I mean each gear is going to have because this backlogs, when these gears come in contact, this is ideal condition. What will happen? The rotation going to be changes. That change, it will causes the change in speed ratio. Then you should avoid this kind of back loss. Okay, this is the referring the gap between the pinion gear teeth and the gear teeth. This the gap is forming the backlogs while function transmitting the power. Now I come to this
Sir.
yes.
So time up, sir, 9:35.
9:35. Okay. Okay. Next tomorrow we have a class, right? Okay. Tomorrow I would like to take 1.5 hour class, Kalyan. We have a class 11 o'clock, 10 to 11, right?
Oh, yes, sir.
So I will take up to 11:30 tomorrow.
Okay.
Yeah. We'll stop here. Yeah, please go ahead. If you have any doubts, only 66 students are here.
Some.
Sir, one doubt.
Yeah, tell me, Karthik.
Sir, during crowning, how do they strengthen the surface of gear tooth, sir? Is it surface? Is it through surface hardening, sir?
Surface hardening. Yeah, good question. I thought to tell you, but I forgot. Surface hardening.
Okay, sir.
Crowning
Okay,
is
sir.
nothing but surface hardening only.
Okay, sir. Thank you.
Yeah, thank you, Karthik. Nice question. Any doubt, guys? Okay, any doubts? I'm closing meeting, Kalyan.
Yes, sir.